everybody. I'm going to be talking about real advances in Android malware, and basically things that attackers are doing now to improve upon just sending out SMS messages. Let's look at some numbers up first. Right now, what we see now is basically a mix between regular malware and what we call potentially unwanted programs. These are your spyware, your adware, your hack tools, things that you may or may not want on a given platform. So it's roughly about 50-50. So it's not just malware, it's not just a bunch of things out there. There's a change now in what we're seeing amongst what attackers are doing. The actual breakdown, it's really not SMS numbers. Okay, SMS is really over, let's see how many. Still a good percentage, but we're seeing a lot more attacks like backdoor botnet attacks, things that send out use information to an attacker, like your IMEI, your IMSI, basically identities and identifiers that help a attacker identify your phone. They generally aren't used to basically attack your phone so much nowadays. We're seeing they're more designed to basically give an attacker a way to count how many infections they have. So if you're running a botnet, you say, okay, I've got 100,000 infections, or I've got 1 million infections, and I can tell by the number of individual identifiers I've got. That's more what we're seeing now, than the bigger numbers, than actually people just going, okay, we're going to send out a quick message or a quick premium rate SMS message that costs you like $1 a message. Something more than that. Okay, so say you're an attacker that's trying to like start up something like bypass antivirus software or anti-malware software and get onto a phone or get undetected or go do whatever it takes. What kind of situations would those be? I mean, this would be like if you had your own SMS sending Trojan that sends a bunch of SMS messages, you're going to get caught very quickly. And so there are ways to avoid that. Okay, or maybe you're running your own botnet. You're saying, okay, let me put it together and infect 100,000 hosts. Now, if you don't use special techniques, maybe encryption, some other techniques like that, your co-workers or your no, I got it. Can I just pick it up? Okay. Okay. So a couple different ways we can look at this now. Say you've got your own botnet and then someone takes over your botnet, you're in bad shape. So you want to use technique like encryption or some advanced technique to avoid someone else taking over your network or invading your network of infected devices. Okay, so now you've come up with, or maybe even better, maybe you've done something like John Oberheid and then researcher Charlie Miller have done, where they put out an application that downloads code from their server, or in the case of an attacker, from the attacker server. But no one's going to run your code because it's not very interesting. So what are the different ways you can do that to get bypass detection and to bypass being boring? Let's take a look at these tricks. First step, once again, like the botnet situation where you've got 100,000 hosts infected and you've got a large network of victims there and zombies or whatever you want to call them. The question is, how do you make sure that someone else doesn't come over and take over your account? You're not worried so much about being detected by antivirus or security software or whatnot because you're making money. Why would you worry about that? You're worried more about someone taking over your cash flow and your network itself. So what do? You encrypt your network traffic rather than encrypting, like, say, each individual copy of your malware. So these are simple things, like the very simple techniques, and they're advanced techniques. Simple techniques are like hiding your what message you're sending or whatnot, or hiding configuration files. Configuration files like minimal encryption, like substitution cipher, something simple, something just to avoid someone else easily taking over your network and taking over. I guess that's basically it. More complex techniques use like a better algorithm like AES or DES or whatnot. Droid Dream, I believe, used DES, and it was basically designed just to encrypt the URLs it was using and to encrypt the traffic that was going over the network. They really weren't worried about anyone detecting them. So what's the deal? You use symmetric cipher. It's a very secure algorithm, and you've got the key stored in your file. Good to go. Can we detect this? Yes, we can. These are not the most advanced techniques out there. Okay, minor thing. I was editing my slides earlier. That should actually read recording calls. Basically, there's malware out there that's able to record your calls. This was done initially by academic proof of concepts, where they said, okay, let's see if we can record audio and do that. It took about 6 months after the academic proof of concepts to actually see malware in the wild doing that. And they've done things where they've gone after interactive voice response and touch tones and all that. Not the most interesting parts. When we've seen them, we've seen a couple of different variants. They do a little different technique, but it's basically all about recording audio. Not that impressive, not the interesting parts. Then we've got something like this, where malware updates. This is two different ways we can do this. One is by actually having real updates, and the other one is pretend to be an update. And the pretend to be an update is basically what we'll cover a little later about fraud as a technique and attacker trick. It's basically where you pretend to be a legitimate update for, let's say, Angry Birds or for an actual Android operating system, and you're trying to get on there. The main thing is, if you pretend to be a system update, when the user sees, oh, it's a system update, and it says, oh, it's requesting install packages or some other high-level permission, they're probably going to approve it because it's a system update. So I mean, it's a little bit of social engineering there, and it helps you get on device, and that's actually something we see more often than not and as an attacker trick. It's a low-level trick, very simple trick, but still enough people fall for it, so it comes out and it's quite successful. The other option was malware updating itself. This is malware that actually has ways of updating itself from an attacker's server. So it'll either contact a command and control server and say, okay, pull down on some new code or new functionality or new techniques or something, or install someone else's software. We have an example of that coming up a little bit later. Take a look at that. Okay. Right. So generally, real malware updates, they're not visual. You don't really see what's going on, and it's basically a neat technique that they've taken from legitimate software. Your antivirus software updates itself. Your Windows updates itself. Microsoft Word updates itself. Why should malware, right? They're learning. Okay. Another concept in attacker tricks is rooting exploits. Rooting exploits are the same ones you use if you want to root your Android phone. So you say, okay, I want more access to my phone. I want to be able to do stuff with it. I'm just going to use one of the root exploits. And of course, malware authors are doing the exact same thing. They're saying, okay, why should I write my own exploit? Why should I go through all the effort of figuring out new techniques when the rooting community is already doing it for us? Which is nice for the lazy attackers, because they're just taking whatever you have, but bad for them also because I'm not sure they realize this, but since these are public rooting exploits, all of us have access, including antivirus software and whatnot, and we can easily detect them. In the case of some of the major ones, we've got like malware that's actually using the main root exploits, just repackaging them and adding, 18 exploit variants, 26 variants. These are variants where they've just changed the words, a few words around, and included the original rooting exploit. It's not that complicated, not that difficult, but it's something they're doing more and more often, because apparently it pays more to just reuse existing code. Another lesson learned from legitimate software development, but bad for them if you want to avoid detection. Something that's actually more functional. Fraud, basically. Fraud on malware. This is basically different from what do you call injecting code, I believe? Yes. Right. This is completely different. This is where the application just pretends, or the malware pretends to be a legitimate application. So say it pretends to be a guitar tuning app. Okay, it's an app that does guitar tuning. Not exactly. It just pretends it has enough code to pretend to be that. We've got two examples here, really. One is one-click fraud, where it pretends to be basically an adult entertainment app, and it really just makes money off of the victim. And then we have fake token, which pretends to be like one of those two-factor authentication applications. So like if you've got Google Authenticator on your phone, or you got two-factor authentication installed on your Google account, you'll have to fire up the Google's Authenticator app and enter the code into Google every time you log in. So in this case, fake token pretend to be one of those same kind of enter the token applications for a bank, or actually a number of banks. And it really wasn't one of those. It didn't generate. It didn't generate a new code, like you would expect on like an RSA token or something like that, where it just repeats every minute or so. It'll give you a new 6-digit code. It just gives you a random code. You enter your password, and all it does is forward the password onto the attacker. So it's very tricky, very sneaky, but it really doesn't do what it's supposed to be doing. It's just fraud. It just pretends to be something. Actual example of fake token, pretty much. It was customized for like 2 to 3 different banks, and it had code really just to like, okay, put your password, and it gives you a fake code. Really nice concept, really simple thing. Actually got a few people. I think it affected a good number of people. Neat technique, and good enough, just good enough of an app to be able to pull that off, but not good enough to be an actual token app, because that would be work. And I think we've seen so far, since with the rooting exploits and with the encryption, malware authors really aren't about the work. They're about making the money. If they can make the money, they're not going to do any more extra work. Now on to one-click fraud, which is the adult application or fake adult application. It's supposed to take you to an adult entertainment site, but instead it puts out a message every 5 minutes that telling the user, okay, give us some money, because you're like going to be or reported to the police, something along those lines. I forget the exact translation. And basically what it did was it take information from you, would take your Google account number and a few other identifiers to be able to track each of the infections. So tracking the infections and tracking the user and finding a way to get you to basically pay them. It would basically open up the fake website and have you give you a message saying, okay, pay for further access or pay so we don't turn you into the police. Now, neat technique. You ask, who would fall for an app that doesn't really do anything, it doesn't get you, and it doesn't even give you what it claims to give you? Who would fall for that? Quite a few people. We actually saw, detection's not a problem, we detect it, but about, is that number right? 211 people actually fell for this, and they picked up about $265,000 in actual profits from people paying for this, basically this extortion, basically. The bad guys are trying to extort you for installing some adult entertainment software, and they pick up a whole bunch of money. And did anyone get in trouble for this? Yes, because extortion is illegal, and it's something that people can track more easily than not. I mean, especially when you're seeing that kind of money. That's a lot of money. It looks much more impressive in yen, 21 million yen, but still, it's quite a bit of money. So 6 people got picked up and they got arrested. It was kind of neat to see an actual ending result of a malware prosecution. And in one of these 6 people was the actual original author of the malware. So what have we learned so far? Malware authors are lazy. They all like to make money. And yes, they will get caught if they get too greedy. So, we're learning quite a few things here about tricks. Another technique that they've gotten, that the malware authors on Android at least have gotten from the PC side, is server-side polymorphism. Fancy words to say basically they change up every time you go to a given URL for the malware, you get a different copy of the malware, your own personalized copy. How personal? It doesn't have your name in it, but it's designed to, they've changed a few strings, they've changed a little size on it. In the case of this one here, it's gone from about 300 kilobytes to about 500 kilobytes, but basically the internals are completely identical. If you actually take apart, excuse me, if you actually unpack these Android applications, you'll find out that basically the code's virtually identical. The only things that have changed are increase in, say, the manifest file for all 3 of these. Just enough to change the name of the application internally when you install it, and size-wise. So not a huge bunch of things. Very simple thing to do on the attacker side, cost-wise. All they have to do is basically script changes to certain files, and then repack the files, and then give you a new download. That can be done in a few seconds with a script. You wouldn't even notice. You click the link, and you get your link in about a minute. No, not a minute. I'm sorry, a few seconds, really. So every time you come in, every day, every hour, you get a new version. So we collect a few of these, and then we've added detection to say, okay, why don't we just detect the files that don't change, and pick up all the rest. And so while that's very nice initially for an attacker, and it's very lazy for them to change it with a script, it doesn't do as much as they think it does. But it is a nice concept initially, especially if people are just hashing files or whatnot, they're not going to catch that. If you detect actual file changes and whatnot, and unchanging code in the file, you'll pick it up. Things like we've done on the PC side for years. So far we've learned that malware authors like to make money. They're very lazy, and they commit the crimes and are kind of stupid. So sometimes criminals are stupid when they're greedy. Some are more complicated, and we'll see a little bit more examples of people who are a little bit better at that. But so far we've seen people who are not that good at it yet. But these are good techniques. They're nice techniques that did work in certain circumstances, and when done properly. And so one major example, though, of that is Android Fake Installer, which I think we're up to. Well, we're currently more than 25 at the moment, different variants. These are variants that are very similar, but they have changed enough to make it a little different protection. More so than the hundreds and thousands of other server-side variants they have there. These are ones that are actually much different enough. And actually, we might actually have a generic detection for most of these. But essentially, they change up. This thing over here is basically a decompiled Android manifest file. They're including every single one of your applications, and they tell you what the application is and what kind of permissions it wants, things like that. And the things that change really are pretty much names and a few other things in there. So minor changes, easily scriptable, really simple, and that's kind of what they're doing now. Something more fun though, a more interesting technique is injecting code into a legitimate application. This is very similar to the fraud application where you have an application or an app that does something bad. And instead of the fraud where it's a completely fake app that's going to be something that it isn't, this it takes a real application and basically injects its own malicious code into it, like a standard PC virus that infects other executables, other files, other programs. In this case, it's not actually an actual file infecting virus. This has actually been installed into, let's say, 20 or 30 different applications, much like Droid Dream was initially. In this case, we're talking about something called initially Android Mogava, and we called it Android Stamper after we found another variant that did almost exactly the same thing. In this case, we're talking about an Iranian food app that pretends to be, it's a real Iranian food application. So if you're interested in getting recipes for a number of dishes, it would give them to you. It really would. In the background, though, it's doing something else entirely. It's got code in it for basically going after pretty much every photo on every JPEG on your SD card. It scans the entire SD card for every single photo, and stamps a copy of the Ayatollah Khomeini onto every one of your pictures. So you've got family photos, you got your friends and family, and maybe a family picture, and boom, there's Ayatollah in the corner. Maybe you're walking on the beach, you got a picture of you and your significant other walking on the beach, and boom, the Ayatollah and his guards are there. Fascinating concept, really hilarious. As long as it hasn't ruined your only copy of your personal photos, but kind of funny. In this case, the code injection is basically just this small little portion of code injected into a legitimate application. Got a lot of legitimate code because it's a real thing, and it's got a little bit that isn't. The thing is unlike on the PC side where a virus actually learns that it's infected something, it'll mark a particular application or program and says, okay, I've infected this one already. I put a mark in there. I've infected that. So I won't infect it again. This one's a little buggy, doesn't even check for that. Which is odd. So, I mean, once again, malware writers like to make money, like to do funny things, like to do a lot of things, and they're kind of lazy. Seems a bit of a pattern on Android. I don't know. Maybe it's just me. The point is, since it doesn't actually check it's infecting every single file or every single photo over and over again, it eventually pushes the size up of the file. So it goes from, like, say, a few 100K to maybe a megabyte or so. So it's really large. It takes up disk space. It fills up your entire SD card. And also, it damages your photos because the only thing solid is the picture of the Ayatollah. Okay, thank you. Okay, in the case of this is code here. We got this little picture here of the Ayatollah and his guards here. So the code basically grabs every image and stamps this photo onto the corner of every one of your pictures. So it has code for that. It has absolutely no code whatsoever to check it's infected. And let's see an actual example of what that looks like. Let's start with this main picture. Here's a picture of President Obama. Here's the picture of President Obama when infected first generation. Hey, look at that! It's the Ayatollah. Look at him. A few generations later, the Ayatollah's looking fresh. Obama's looking a bit peaked. I don't know. It's damaging the picture, and let's look at like a few more generations up. Ayatollah's still looking good, totally fading away. I mean, it's like if you've seen the Back to the Future. It's when Marty starts disappearing when his parents don't get together. You know, it's a bit like that. Maybe that's a too old a reference. Okay. Point is, the Ayatollah gets bigger and bigger, or it's stronger apparently in this case, and your photos start to fade away, but the size of your pictures get bigger and bigger. This is a side effect. This is something similar. This is version B of that app or that malware. This is a Japanese pop group. I think it's AKB48 or something along those lines. They have about more than they're sort of like American Idol or something like that. But it's like they've got about 60 members. 48 used to be what they used to be, the size of their membership. Basically, they have a traveling band where you have about 4 or 5 of them that travel around the country and then sing music. Occasionally, every year, there's like a contest to vote on your favorite bands. So there was an app that allowed you to basically follow the elections where fans could vote on who do they want to be in there, who do they want to be the current touring band. And they had this app, and actually, this little picture is what replaces the Ayatollah. It gets stamped on all your pictures. The trick was the app pretended to be that app that lets you monitor who's winning the elections of this particular band, but instead it actually just posted this picture here. Now this picture is not totally unrelated. This is a picture from another AKB48 contest a year before, where you could see, or not a contest, but like another app that let you see how you, as a fan of AKB48, how you, a picture of you and a picture of one of the members of AKB48, what would your baby be if you mix them together? This was with a sumo wrestler and one of the members, so it was a kind of a somewhat creepy looking baby. Put on every one of your pictures, all throughout, all your pictures on the disc, on the disc, everywhere, all around you, just there. And it's funny. That's actually the most interesting part, because literally the code was completely identical. If you compare this to the previous screen, it's completely identical. The only thing that's changed is the picture, nothing else. So once again, lazy malware authors, they're not trying very hard. Not so much. The ones who are really trying to make money in malware and in Android malware in general are the ones who are running botnets and attempting to make money or resell traffic. Just the same way you do on a PC, where you infect hundreds of thousands of computers and you resell the services of those infected devices or infected computers to other criminals. That's really the only way you make money doing this. Otherwise, you get in trouble, or you make no money, or you get caught. This is actually something a little more advanced, what I was referring to. Android backscript.a. This is basically a fake version. It was code injected into a number of real applications. This specific version is an Angry Birds version, Angry Birds Space, and so it's not really Angry Birds Space. It's just Angry Birds Space. Well, actually, it's Angry Birds Space plus malicious code. And the nice thing about the malicious code, or the interesting thing about the malicious code, is that it downloads the additional attack code. And the additional attack code isn't Android code, native Android code. It, excuse me, it's basically embedded JavaScript. In this case, it uses code from fscript.me, which is a JavaScript to J2ME converter. So basically, you write your code, your script in JavaScript, and it gets loaded by this fscript.me loader and runs in the context of the application. So you can basically embed or code all your attacks and whatnot in JavaScript, and instead of writing them in actual Java, which is loads easier if you've only ever learned how to program the web. Okay. So basically, it loaded this application. Once you run it, install itself, it sends your IMEI, IMZ, bunch of different identifiers to the attackers. So they know who they've been infected, so they can track basically the botnet. So they'll infect maybe 100,000 different people, maybe 1 million people. Depends how well they get along. And then since they're using encryption here for their code for the JavaScript gets downloaded, it's like, oh, okay, that's great. That protects it over the network. So if someone's using I guess Wireshark or something to monitor the network and see what kind of traffic is going over, or basically they're trying to intercept, all they'll see is encrypted traffic. They don't have the key unless they have a sample of a copy of the malware, meaning an infected bot client that has the key. So when we analyze it, we have the copy of the malware, and we can take a look, and we know what's going on, and we can watch the traffic going on. The attackers, or the attackers' competitors in this case, the botnet owners' competitors, don't. So they're kept out. In this case, the actual code that's embedded in the application doesn't do all the work. All that does is provide an infrastructure to run the downloaded code. So when it downloads the code, it downloads the command and control code from the server, from the attacker server, brings it back down onto the phone, and implements a few commands. It's not very malicious at the moment, but currently it's able to install and download an APK or download an APK, meaning download another application from the attacker server and then place it on the on your device, on your SD card. And also it's able to run basically send you to other websites and download and install software. So basically click fraud and install fraud. Just a nice technique, and it's a good way to make money because, okay, installs can generate money. Paper install generates money for people and attackers and whatnot. So they do it on the PC all the time, where they'll install like, oh, maybe that icon program or some other kind of program on your PC. Costs them nothing. It costs you nothing, but it gets them a commission from the person doing the paper installs. The paper install. In this case, we're looking at something like this. It'll pop up a web view of basically one application while it's really installing a second application that's already on your device. Very neat technique, where you have this on the SD card. A little bit more advanced than the other one. It's basically a silent install of software that you don't necessarily want on there. Once again, potentially unwanted programs, not really malware, but really things that you don't want on your device. And it's already on disk, and you want to get rid of it. But that's another story. Point is, this is software that actually stays under the radar, doesn't do any damage to your system, doesn't cause a lot of problems, encrypts your traffic so they can't be taken over easily, and is able to be updated on the fly just by downloading a script from the attacker. I mean, they can, right now it just does two things basically. One was installing the initial adware, and second was basically clicking on links and installing software. Two things. Okay, so how about we do another one? What are possible future improvements? Things that would be good for the attacker. May not make them money, but good for them. Like say something destructive, like wiping someone's phone. Destructive, doesn't make you any money. Maybe not a great idea, but they can do that. Another thing is reselling malware installations or reselling other installations. So you start with one program that you install. Maybe they can install 4 more programs for somebody else. They can resell. I say they have a botnet of 100,000 users. I picked that as a number, but it could be 1 million. It depends how good your initial install is. In this case, what you do is, okay, I have 100,000 botnet available, what we call cell phone botnet available for you. I'll charge you, say, 20 cents for each install. So you give me the package, I'll send it out to my network, and they'll install on all of these devices, and you'll get the credit from your pay-per-install provider, or your commissions from whoever's selling you that software. So it works out that every person in the chain, so there's the people selling their software, the people wanting to make a commission on that software, and the person who has the botnet. So you've got a bunch of people making money on this entire transaction. And interestingly enough, not getting caught, because they're not actually doing damage, they're not actually stealing money from banks or whatnot. So it's a lot harder to track them because it's, I guess, low-hanging fruit or something along those lines, where it's not as bad as it could be. But it could be, always get worse, but we haven't seen that to date. And we have seen a trend actually where people are saying, okay, the attackers are saying, it's better to make the money than to get in trouble. So they'll hit, say, 1 million users for a buck a piece, and that's $1 million. Do they need more than that? No, they'll hit another than a couple of users or do a different technique. It's more of a hit and run than a stay and wait and run something like that fake one-click fraud one, where you get arrested. So a little better than that. Let's actually look at a couple more things. Academic and professional research. Something like this. This is not as complicated, but it's starting to get there. There was a version of something called SoundComber, which was able to read, like, I mentioned that earlier. Actually, probably more closely be something called TouchLogger. That's actually mentioned at the bottom. This is basically software that reads, like, whenever you have like an Android phone and you have the soft keyboard or any device like that, every time, if you hold the phone in your hand and you tap the keyboard with your fingers, at some point, I mean, the sensors built into the phone, like your motion sensors or whatnot, they move a bit. They move enough of a pattern that you can detect any given user typing in, say, the digits 1 through 9. Something easy like that. Very neat concept. Yeah, it's like, it makes sense, and they've actually done the research on this, and it works. In the first instance, TouchLogger, it was basically 2 pieces of Android software. One, there was a trading software that would learn the particular patterns of movement caused by one individual typing in numbers. And a second one that used that training data to basically figure out when this user was typing in their password or their passcode or whatever it takes to unlock their phone. And that was a nice concept, but it was bulky because you had 2 pieces. This new variation, TouchLogger, puts everything in one place and adds a little front end on there, where it's now you're playing a little icon matching game that happens to have the icons all in the range of the 1 through 9 or 0 through 9, and the other, like the asterisk and the pound key, you know. All the keys happen to be right in the same location. You'll see it's right in the same. Very neat concept, but instead you're playing a game. So it's engaging, and it gets you to basically train the software on how you press the buttons on your keypad. So when you lock your phone, the attacker gets access to all your information. Neat concept. Totally academic at the moment. I mean, yes, this is an improvement on other academic software. About 6 months in there. We haven't yet seen that in the wild in malware. Not sure why. Probably because there's not a lot of money in taking over any given Android phone, unless you can sell ad clicks or go further, like we've seen before where people try to take over, or a botnet they'll try to take over the. Oh, 1 second. You have a question? Okay, the question was how many users who their passcode to unlock their phone, say it's a 4-digit PIN, how many of those are the same as their bank or ATM PIN? That's a good question. I don't actually know, but like the case of real passwords and other passwords you use in different accounts. There's a lot of repetition, and my friend here is an actual pen tester, so I mean, this is actual. We're- Oh, okay, if you have enough information on the user to be able to install this, you can do what exactly? You've got a lot more to go with, you're saying? Okay. And you possibly have their ATM PIN. Yes, okay, I agree with that. Yes, that's very likely. This is the truth. Truth from a pen tester does this every day. Yes, it's the truth, yes. If you use a common PIN, you'll probably use it more than one place, and possibly on your phone. So this, once again, argues for using this in malware, but we still haven't seen that. This might be tied into what this pattern we're seeing where the attackers are enjoying just doing silly things and making quick buck and not really trying hard on their own. It's not like the attackers are putting their own R&D into developing exploits or developing new techniques like this software like this that reads your PIN, something like that. They don't quite have that. Who's actually doing this work? Academics, other researchers, people like. Okay, this is actually an overview of what that does, and to maybe give you a little bit of better idea of the touching and the pushing of the buttons. But it is the same concept, and truthfully, if you use your PIN and your password in one place, you very likely will use it somewhere else. Let's actually look at two other interesting researchers, John Oberheid and Charlie Miller. I mentioned them earlier. So these two guys, they're really good at going after mobile phones. They do some interesting things. John put together an app a few years ago, and at SummerCon he announced it, called Eclipse Trap. This was basically a piece of software that pretended to be what do you call it? A preview app for the latest Twilight movie. I think it was Eclipse at the time. That's why Eclipse Trap. So it was a preview app to show you like what's going on in the new movie. This is once again playing on the fact that it's a very popular movie. There are a lot of people want this app. They're probably going to download it. What did it actually do? It was just a fake app that did just enough to show you that, oh yeah, we're like an Eclipse thingy, Eclipse preview app. But meanwhile, it was downloading native code from Oberheid's server. So kind of like what we saw with Backscript, where it downloads code from the attacker's server. It was able to download exploits and code from John's server. Now, Charlie Miller did something very similar a few years later. I think it was on the iPhone, actually. It was a stock market app that was able to download code from his server. Neat techniques. So these are two guys who are really good at doing interesting things on mobile phones. I mean, Charlie really is the guy who was known for the first Google Android exploit, and I think the first public iPhone exploit. So these are guys who know what they're doing. They actually looked at Google's bouncer technology. Bouncer is a thing that Google provided to basically provide some kind of, vetting for Android apps. So we see people talk a lot about, oh, Android's so open. Yeah, you can get whatever you want into the app market, and it could be malware, it could be anything, it could be a lot of bad stuff out there. Where's the protection? In this case, Google's bouncer technique was, or bouncers. What's the proper term for this? It's in the name, really. If you're at a nightclub and there's a guy at the door saying you can come in, you can't come in, that's basically what the software is. It tells you that you can or cannot be an application in the App Store, or the Google Play Market, it's called now, I think. The problem is, at least from security research side of security researchers and people who are interested in security in general, is that it's security through obscurity. It's like saying, okay, no one knows anything about this amazing bouncer we have that protects you from all of the applications. They know nothing about it, so they can't break into it. They can't bypass it. This is good, right? Not really, especially when you have two guys like Charlie and John who know a lot of stuff. They basically fixed this last problem here. They produced basically an app that was submitted to the market and it was able to basically provide them a connect back shell into the Google's network. So what they found out was, one, Google runs these apps, your app, on their internal network. Two, it has access to the internet. Uh, that's how they were able to connect back to themselves. Three, they found out they had a few things, interesting things, like I think there's a picture of Lady Gaga in there. There's like one contact in there. I mean, it's like they found out the email address of the Google account on their device or emulator or phone. I mean, they were able to discover a whole bunch of things from the background, and they were also able to detect accidentally, because they happened to be running when a live person was testing the apps. Is that Google uses live people to test the apps as well, and they noticed that these guys were connecting back and touching the files and looking around, and it's like, good concept. Maybe you should not do that while you're on there. But the point is, the Google's bounty is like a really really good start, very good start compared to not having security of any kind. So it is an improvement. It's getting there. It's not quite there yet. They could help if they did a little bit more communication between researchers like Charlie and John, and to provide basically input on how to secure a situation like that. Like, okay, you've got a bunch of malware on there. It's not sufficient to run just one or two scanners or whatnot, or it's not enough to just have people run them, to run the apps manually, because what these two guys kind of came up with was basically saying, if you run your app for about 5 minutes and do nothing, wait to do the malicious actions until after about 5 minutes, you're pretty much bypass the entire bouncer process initially. Obviously, Google improves upon all their techniques. Like when their audio recaptures got cracked, they improved upon that as well. So I mean, they've got people, they've got a lot of good work, and they're doing well. But this is the initial concept, and it's interesting. The interesting thing is that this is what's being done by researchers, professional researchers, and academic researchers, and not actually criminals. That's the really interesting part of all of this, is that the criminals aren't really doing anything at all malicious. They're there just to make money, and it's a good time for them now. It's a bit like doing the, I guess, it's like having a Windows PC before we had all the protections, before we had all the fancy malware, before we were all had the fancy defenses for fancy malware. It's like getting in on the ground floor for them. They don't have to try hard yet because we don't have enough security infrastructure in place. We don't have enough security software. We don't have enough things in the back end on the network. We don't have all these in place yet. But the time is coming, and eventually what happens is that the bad guys will get better, much like the backscript.a, much like a few other botnet controllers and whatnot. They're getting better. They're going to get better, and we have to basically go after them and basically provide more security. And I think that's the last thing about it. Are there any questions on that, actually, on any of these?
Sit up here, dude. it tells you to pretend I'm in the next little bit.
We're going to go ahead and get started. This is the hilarious Matt Johnson with PowerShell Be a Cool Blue Kid.
Really?
The hilarious. I'm setting you up.
Hello? Hey, all right, cool. Let's do this. All right, this is my talk, PowerShell Be a Cool Blue Kid. Let's get started. Here's some of the stuff we're going to go through. I'm going to give you a little intro of myself. You really have to actually listen to that. Some basics of PowerShell. We'll go over some files and file system stuff, as well as user access, a little bit of systems management, and then some wrap-up. I'm a system analyst for a nonprofit organization in Southeast Michigan. I'm also the founder of the Michigan PowerShell's users group, which is kind of not doing anything right now, so that's hopefully going to change later this year. I am a moderator on the Hey Scripting Guy forums. If you're not familiar with the Hey Scripting Guy website at Microsoft, it is an area to help you go learn PowerShell. Gives you actually things you can use in your job instead of here's a variable, print a variable. It's actually really cool. But they have a forums, and I'm a moderator on there. As well as a judge, Microsoft has scripting games every year to help you learn PowerShell, either from basic or advanced. Judging is fun, but that's a lot of scripts. So you should try it out if you want to use PowerShell, learn PowerShell. It's really cool. I'm a member of MySec, whether they like it or not. I'm an avid gamer and a huge sports fan, so if my phone goes off in the middle of here, it's probably the White Sox losing. And I'm a father to a future hacker. He does crazy things that I don't even think a 2-year-old could do yet, and a husband to a wonderful wife who has him this weekend, and I feel bad for her. I'm not an expert. I like to pretend I am, but I'm really not. I'm really MySec's PowerShell expert, and yeah, they probably suffer through that. There's a ton of sysadmin stuff in here. It's blue side. That's what I normally do. I don't do red side, but a lot of sysadmin stuff does tend to technically translate over to the blue side. My employer doesn't feel this way, or either does Microsoft. I feel like every slide has to have that line in there, so that's why that's there. And as you find out, I think I'm funny, and I talk too fast. So get over it. If you don't like it, there's the doors. So, all right. Let's get going. Anyway, hopefully you all have seen this if you use Windows 7 and up. It's in the other versions of Windows as well, but you should use this. Looks like a DOS window, but it's a lot cooler than the DOS window. If you haven't heard, what PowerShell is a task automation framework. I automate basically everything, from tweeting at these guys down here in MySec to sending my wife the grocery list. It's installed in every Microsoft operating system. It is getting better, so much better. Once you start using PowerShell and manage Windows, there is literally, you're going to wonder why they haven't done this in years. I heard someone comment today saying that PowerShell makes Windows actually usable. Well, I said, well, that's kind of cool. And the current version is 3.0. I have some 3.0 stuff in the very end here, but it's still new, and I didn't want to give you guys that stuff. So there is tons of support. I support everything on here except the compellent one on here. The compellent one's on here because I'm going to do a talk later this year or next year with Wolfgang Gorlick, some DevOps stuff. But there is deep integration with all these products. You can, I don't remember the last time I opened actually a GUI to manage half those products, which is kind of cool. All right, we're going to go over some little basic language stuff. If you know what PowerShell is, you can check your phone for the next little bit. A commandlet is like a command, but it's a lot cooler. It is, that's Microsoft's actual definition, but it is a command. You can make your own, which we'll get into in a couple minutes. That's when you read about PowerShell, you're going to hear the commandlets. It is, there's some examples up here, like get help, write host, register event object. It's a very simple thing to pick up and learn. You type in get-command, it'll give you a whole bunch of commands, and it's actually You can look at it and see what you want to, you can find out what you want to do. There's a naming convention. When you get scripts or download stuff off the internet that is PowerShell, it should follow the verb noun format. If it doesn't, then you might want to point them to the verb and the here's how to write PowerShell code stuff. But it's you'll see a lot of people don't use it. But there is a naming convention, and you should stick by it. There's 98 verbs that Microsoft uses, like show, get, register, stop, terminate. Never use terminate, but that's cool. Then there's aliases for those people who don't want to type out get-mailbox. I believe that's GMB. There's get child item is actually dir. That's the PowerShell version of dir, but you can type dir and it'll do the same thing. Or ls for you Unix guys. You should not use, this is just a side note, don't use aliases in your scripts, because if you share it and someone's like, well, what the heck is that? It makes it easier to read if you type the full command name. And you want to see all the aliases, get-alias. You can make your own too. So if you don't like to type, you can make your own. You can alias your whole thing if you want. And get help is your friend. Make sure that you, thanks Chris, you use get help. I use it all the time. If I'm not typing get help once a day, I'm not trying. Yes, they do. Tab completion is in the console and the built-in editor. They give you an editor too, which is really cool. It will now version 3 will tab complete in the editor. And IntelliSense too. Yes, IntelliSense. All you people who use IDEs, IntelliSense is like awesome. Wolf likes IntelliSense. For the Unix guys, don't worry. You can type things man, cat, cp, ls. There's multiple aliases for a lot of commands. I think it's kind of weird, but whatever makes people happy. Now we're going to talk about running scripts real quick. Out of the box, you download a script from my website, my GitHub site, whatever, you won't be able to run it. You have to change execution policy. And when this first came out, people were like, oh man, it's a security feature to stop you run scripts. And then people like Relic pop up, or Matt, who writes the PowerSploit module, show that, really, when you run PowerShell.exe, you can say bypass the execution policy. Execution policy is just basically stops you from doing something stupid, like out of the box. You can get by it, but it's there. You can set it system-wide or based on user. I'm a fan of just setting it by user instead of globally doing that. There's a switch in a command that you can run, but that's on the internet, and we're not going to cover that today. And it is not a security measure. It's just to stop dumb people from being dumb. This is what I love about PowerShell, is you can make tools. How many times have you like, man, I wish I had something that I could do to do, I have X, I need to repeat it a million times. It's what I do a lot of the time. I make my scripts reusable, shareable. I share them on my blog. I share them with MySec members. I share them all over the time. That is one of the awesome things about this. Then there's a huge community behind making tools and sharing tools. There's Poshcode, there is the Microsoft site for getting scripts, there's tons of different places. So this literally it's like bash scripting, but there's a lot more formal stuff behind it. This is part of that. Modules. Modules are a bunch of scripts or a compiled code. There's some other stuff that you can put together to make and share those tools. One of the examples I have later is I have a module to help edit host files. And it's just 3 functions that are pieced together that I can import into my session and go along. Well, I'll show you guys that in a little bit. It is good for repackaging scripts and sharing scripts. PSCX, which Wolf mentioned in his .NET talk earlier, is a great collection of scripts, and it's always updated. Office 365, you can manage the entire online web version of Microsoft software via that way. And NTFS security is another cool one that we'll get into here in a minute. How many times have you run a command and wish that you knew what happened, what the output was? PowerShell has these 2 wonderful commands built in called start and stop transcript. They will record your command and the output for everything you do. So say you're changing a bunch of users over to a group. You can log that whole thing so you have actually a backup of what you did. So you can go back and say, yeah, I actually moved that on this day at this time. So it's really cool. A couple last minute notes. I don't know how many people are familiar with programming and yada, yada, yada. Everything's an object, which means that you can take it and pipe it using the pipeline and keep on manipulating stuff until the end. Usually when you build a PowerShell statement, the end thing is always your formatting. So I'm going to take users, I'm going to modify them, and then I'm going to print them out into a text file that I did all this work. Pipeline, like in Unix, Linux, you can pipe one command to another to do variable things. All variables are prefixed by a $sign. And you can name them anything you want, except there's some special variables. I don't recall how many there are, but there's the underscore $sign, which is the current thing in the pipeline, or true and false, yada, yada. And anything in this talk works in version 2 or above. So let's talk about file permissions. I don't know about you guys, but I hate file permissions. It's like literally is a pain in my ass. I don't like it. You can GUI, yeah, okay, and xcals and cals. At least I know a lot of people know how to use them, but they're really not user friendly. They really aren't. So built into PowerShell, there's get and set ACL. These things are painful to use at best. And I'll show you an example of that in a second. But if you're using this, you are, you might want to be drinking on lunch. All right. So here's a demo of actually how bad the permissioning in Windows for PowerShell for this is. Here we're going to create a directory real quick. Yeah, look, it already exists. Well, that's okay. This is the command to get the ACL list for that folder. And format list is going to print it into a thing that we can easily read. You see here, there's a whole bunch of stuff. Administrators, NT system, and authenticated users. Basically, this is the default access. So here I'm going to store the ACLs into a variable so that I can act upon them. Here is this right here. We're going to say that we're going to set access rule protection. It is just something you have to do in there. It's I've never ever changed that. So here's what the next thing we're going to do is we're going to set a rule. This is an access control rule that gives domain admins full control over that directory. That is how long. That is painful to type a command prompt. Just literally painful. Here's another, and then this right here, this command will add it to this variable so that we can make sure that that gets applied. We're going to go through and do this again for domain users, and they're going to get the modify permission. We're going to add it to the rule. Yeah, that's fine. Yeah, my demo didn't work. It did earlier today. So basically what this is going to do is, when it does work, and demo gods, I taunted them earlier. This basically will set all those permissions on here. All those lines just to set permissions on there, that's painful to me. So you can script it, you could put it in there. If you're going to do the same permissions over and over, you could write a script and send it a folder variable and off it goes and it'll permission that folder for you. Or you can write a function and pass it off. I have 2 functions included in my on my GitHub thing in here that actually takes and removes the permission to use USB on a computer. So I had to do it for some DoD project that I was working on. But really, basically, to use this, you have to spend some time in the MSDN documentation. And I don't know how many of you really like MSDN documentation. I don't. Oh, yeah. Look at that. Wolf likes it, too. You guys might want to bond. He does. Yeah, most people have Google as their homepage. Wolf has MSDN. So, hey, there is some help though, and this gentleman Raymond Andre from Microsoft made a nice little PowerShell module to help out with this. So I'm going to show you a little easier how this actually goes. But first, I'm going to delete that folder.